So let's have a look at the other features of them. I need this to make it straight. Okay, so let's have a look at the properties of even and odd function that we can actually apply in our calculation later. For example, let's say if I wanted to find what is going to be the region from negative p to p of an even function. So I've highlighted over here. So what is my region from negative p to p? So it's going to be from here until here. If you notice, so we have seen this sort of function before. So I'm referring to what we have seen up here. So when a and b are symmetric, they are side by side. Instead of having to integrate and come out with two integrations, I can simply integrate one of the region and multiply that by 2. So that is what I'm going to do when we have even function. In our calculation later, if we have something that is an even function and we are going to find the area from negative p until p which are symmetric, for which these two curves are symmetric because they are the image of each other, automatically, instead of like having to integrate all the way from negative p and p and having to do two integrations, so what I can do is I simply can just integrate from negative p. So instead of like integrate from negative p to 0, I'm not going to do that. I'm going to integrate the region on this side, because I know that this is going to be a positive value and this is going to be a negative value. I don't want to have negative numbers in my integration. Like, it's going to give me a higher risk of doing mistakes. So therefore, what I'm going to do is I'm simply going to integrate from 0 until p of the function f of t dt. I know that this is going to give me only one of the regions. So it's going to give me only this region over here. So when I wanted both of the region, so what I'm going to have to do is I simply going to multiply this by 2. So when I multiply this by 2, automatically now I have covered all the regions. So from negative p until p. So that is what we're going to do when we have an even function. Okay, what about if you have an odd function? Odd function is going to be even better. So if I wanted to know what is going to be the region from negative p to p of an odd function, if you notice, so the features is that one region is going to be at the bottom and one region is going to be at the top. And of course, because they are the image of each other, they are symmetric as well. And we have seen the same case before, so which is referring to this diagram right here. And we know that if we were to add up both of the region, the top and the bottom, so we will end up with a value of 0. So that is why if you integrate an odd function from equal distance, which is going to be from negative p until p, that is equal distance because the distance is the same. Okay, this is p unit, this is also p unit, just that one is on the left, one is on the right. Automatically you don't have to do the integration, so this is definitely going to equal 0. That's it, as simple as that. Okay, how are you going to apply this? Let me give you an example. So let's say in your integration you come across something like this. You're going to integrate from a negative pi to pi of the function cos of 2 pi t dt, and from what we have discussed before, even from the graph that I've sketched, we know that cos 2 pi t is going to be an even function. So therefore, instead of like integrating the whole region, so I can simply change my limit. So previously my limit is going to be from negative pi until pi, so it's going to be from here. So this is 0. I'm going to integrate from negative pi until pi. What I'm going to do is, because I know that it's going to be even and they're symmetric, I'm going to integrate only half of the region. And half of the region is going to be from 0 until pi of the function cos of 2 pi t dt. But however, I know that this is going to be only one of the regions. It's going to be only the region right here. So when I wanted to find both of the region, so what I have to do is I have to multiply this by 2. So that is going to be the features of an even function. So you can change the integration limit and you have to multiply that by 2 in order to find both of the region from negative pi until pi. And for the case of odd function, so it's going to be even better. So for example, let's say if I want to integrate from negative 2 pi to 2 pi, it has to be the same so that they are symmetric, of the function sine of t dt. I know that if I were to sketch this function, because this is going to be odd from what we have seen before, and it's going to cover from negative 2 pi to 2 pi. So we know that somehow if I were to sketch this graph, I'm going to end up with one region at the top, one region at the bottom. So it might not look something like this, but that is going to be the idea. So we know if it's an odd function, automatically we're going to have two regions, one at the top, one at the bottom. So automatically you don't have to do the integration. You can simply right away write that the integration is simply going to be 0. So that is a very good feature of odd function. So whenever you have odd function, you should be very thankful. Your integration is going to be simpler. It's simply going to be 0. You don't have to do any integration. But for the case of even function, what you can do is you can change the limit. You can integrate half of the area and multiply by 2. Okay, so that is going to be the second properties. Let's have a look at the last property. This might be confusing for you guys, but when we do the calculation later, so this is what we're going to apply. Okay, so the third property is going to be in terms of this. So if for even function, f of negative t is going to equal f of t. So whether t, so when we have axis, so this is going to be my negative area, right? And this is going to be my positive area. But for the case of even function, what happened is that whether it's going to be in the negative area or whether it's going to be in positive area, they are going to share the same value. So what do I mean by that? So for example, let's say if I have cos of negative pi, so the value is going to be the same as cos of pi. You can try this by using your calculator. So that's going to be what happened. So whether the angle is negative or positive, the value will be exactly the same. Or if I were to give you another example, so if I have cos of let's say 200 degree, negative 200 degree, it will give us exactly the same value as cos of 200 degree. So this can help your calculation later when we start with the Fourier series. And that is going to be for even function. For odd function, the property is that if you have f of negative t, it will be the negative value of f of t. For example, let's say if I have sine of negative pi, it's going to give us the same value as negative sine of positive of pi. Or if I have sine of negative 50 degree, that will be the same value as negative sine of positive 50 degrees. So you negative the value. So that will be how it goes. Alright, so that is the difference between even and odd function. Okay, aside from this, there's going to be one more component that you're going to need to know that we're going to use in our calculation. I know that this is a lot of things already, a lot of concept already, but please bear with me. We haven't even started with anything. We haven't even started with the calculation. It's going to be like a lot of concept, but if you understand it, it's going to be worth it when we start with the calculation. So let's see if I have this as my function f of t, and this is my g of t, and what happened is that we're going to multiply them, ft multiplied by gt. Okay, what happened is that if I have an even function and I multiply that by another even function, so the product is also going to be an even function. If I have an odd function, I multiply that by another odd function, so the product is still going to be even. So basically, if you notice, what happened is that when the property are the same for both ft and gt, so you will come out with even functions, right? So if I have, on the other hand, so let's say if I have an even function, I multiply that with a opposite property, which is odd function, so the outcome is going to be odd. Or if I have an odd function and I multiply that by even, so it is still going to be odd. So when you multiply function with the opposite property, they are not the same, so the product will come out as being odd. So if you want to remember this, it's going to be the same as positive and negative. Like, let's say if even is positive, you multiply that by a positive, so you will get a positive. And if you have odd is resemble as being a negative, when you multiply that by negative, it is still going to be positive, right? So that will be the same idea. And if you have positive multiplied by negative, it's going to be negative and so on. But just bear in mind, when the properties are the same, the product will become even. If the properties are the opposite, the product will become odd function. And another important property is that for the case of neither, so neither, remember, it's a very tedious function to deal with. If you have a neither function, so whether you multiply that by an even function or odd function or even another neither function, it is always going to come out as being neither. So that will be the case of neither function. And how are we going to use this? It's going to be when you come across something like this in your calculation. Okay, for example, in your calculation, let's say you come across a negative pi to pi, an integration of t sine of t dt. Of course, we know that this is going to be integration by parts, but instead of integrating this and having to substitute a limit from negative pi to pi, which is going to be quite tedious, now when you have a look at this, it looks like it's going to be easy, but no, when you substitute later, it's going to be very, very tedious. Okay, so you wanted to simplify that. How do we simplify that? Based on the property. Right, so now, so t, this is t to the power of 1. Because 1 is an odd number, we know that t to the power of 1 is going to be an odd function. And sine, we have seen that before, sine is always an odd function. And when you multiply odd function with another odd function, the product is going to be odd function. And, it's going to be even function. Remember, when it is the same, it's going to come out as being even. So odd multiplied by odd is going to be even. So we know that for the case of even function, they are not we're not going to exactly sketch this, but if you were to sketch this, you will definitely find out that they are going to be side by side. So there's going to be one region, there's going to be one region. Remember, even function, the characteristic is going to be side by side. So that is why instead of integrating from negative pi to pi, so which is going to be two regions right here actually. So what we're going to do is we're going to integrate only one of the region, the positive one, because it's going to be easier to integrate when you have a positive pi instead of a negative pi. So the integration is going to be from 0 until pi of the function that we wanted to integrate, which is t sine of t dt. But then again, so this is only half of the area. When I wanted the whole area, I have to multiply by 2. So that is when we have an even function. Okay, let me show you another example. So let's see now I have integral from negative pi to pi of the function t square, so sine of t dt. I simply changed that slightly so you can see the difference. So t square over here, it's going to be an even function because 2 is an even number. Sine is going to be the same as before. So sine is still going to be odd. And according to the property that I've written up here, when you have even multiplied by odd, the product is going to be odd. So the whole thing over here is going to be odd. So we are not going to sketch this, but if we were to sketch this graph, we know that we're going to have two regions that are symmetric, but one is going to be at the top, one is going to be at the bottom. They are going to have the same value because they are symmetric. So that is why when we add them up together from negative pi until pi, we want to find the region. We know that this is going to be 0. You don't have to do any further calculation because it's odd and it is symmetric. Automatically, this is going to give you a value of 0. Right? So I hope you can listen to this over, if you don't understand, listen to it over and over again. Consult your lecturer on what does it mean, what does that mean, because this concept are going to be very, very crucial when I start with the calculation on the third video. So these are going to be all the things that I'm going to apply, like when this is even, when this is odd. So when it's even multiplied by odd, how do I simplify the calculation and such? Remember? So listen to this over and over again if you need to, right? So I'll see